The question is now, evaluate double integral xy x plus y dx dy over the region between y equal to x square, and y equal to x. First, tell me, what is this y equal to x square?
Sir, it's a parabola.
Which side?
Upward parabola.
Upward parabola. X square, even power of x indicates symmetry should be about y-axis, correct? So this first we should draw this parabola. We say this is my rough sketch again. Say y equal to x square. So next we have to draw the another curve, say y equal to x, and this is, yes, it is a very simple, it is a straight line passing through the origin, making an 45-degree angle. If you're not getting, just put x equal to 0, y is 0, x equal to 1, y is 1. So this is the line which passed through the point 0, 0 and 1, 1. So that way also you can draw it. So I'm just taking the rough sketch here. So this is my line, y is equal to x. Now, as we have these two curves and they are intersecting at two different positions, we should know the coordinates of the intersection. So how to get the coordinates of intersection? Just replace y by x in this equation. We get x equal to x square. When we put y is equal to x, so we get x is equal to x square. So we get x square minus x is equal to 0. If you take x as a common, we get x equal to 0 or 1. Okay, when x is 0 or 1, and if you replace in any of these points, so then y is also 0 or 1. So what should be the point of intersection? These point of intersections are, first one 0, 0, and what about this other point?
1, 1.
Sir, 1, 1.
1, 1, correct. Now tell me which strip you are going to take it, or first of all the region is bounded between these two curves, so we should highlight that region.
Yes, sir, 1, 1.
Yes, correct. So this is the region of integration which is between the two curves. Okay, and now the nature of a strip. Which strip you are going to take it, vertical or horizontal? Yes, you can take any one, but choice is yours again. So let I draw a vertical strip. So what should be the lower limit and upper limit?
Sir, horizontal.
No, now I taken a vertical now. Okay. So what about the lower limit?
0.
Not 0.
X square.
X square is the correct answer. Lower end is varying on the curve y equal to x square. Upper end is varying on the
Y equal to X.
y equal to x. So that becomes a lower and upper limit. And now here I will tell you one important thing, that someone is asking me the doubt at the beginning, sir, it is the wrong limits are given, but you will observe for this integral only
Y is equals to x.
just 1 minute. So as I taken a vertical strip, the order I selected is a dy dx, and the limit of y are from x square to x. And here few of the students have the problem, x square is a greater than x, they think, and they think x square should be upper limit and x should be the lower limit. That is not correct, because on the interval 0 to 1, x square is a less than x. Okay, because of that x square become a lower limit. So whatever the limits we get, we get exactly correct limit from the diagram only. So yes, x square is a less than x square is a less than x on this interval 0 to 1, and because of that this is the limit. But at the beginning few of the student asking that yes, that there are wrong limits, so that should be interchanged, and that is not correct. Okay, so this is the way you get a limit. What about outer limits now? Outer limits for x?
0 to 1.
0 to 1, correct. So to get the outer limits, the simple thing that you should keep in mind is just you have to look the minimum and maximum value of x, because that x is outside. So x minimum is a 0, x maximum is 1, and that about the outer limits. They are 0 to 1. So this is the way we get a limit. Now similarly you can get the limits with a horizontal strip also. Choice is yours, you can do it your own. Now the small part is left here, that we have to evaluate this double integral. We do the integration one by one. So first we should integrate it with respect to y, treating x like a constant. So we can rearrange the terms so that integration becomes simple for us. So I will take this x square to x as it is. So as x is a constant, okay, or I will take all things inside, x square y plus xy square dy dx. So what I done, simply just I take an xy inside the bracket. Now tell me the integration. Yes, what is the integration? Integration of this bracket. Quick.
X square y square by 2
Very good.
Plus
plus
xy cube
x
by
upon
3.
Xy
yes
cube upon 3. That is correct answer. And limits are obviously that x square to x dx. We have to just put upper limit and lower limit first. So when we put upper limit, you will observe we are replacing x here. So x square into x square become x4. x4 by 2. This is also x4 by 3. That about upper limit. Now I am going to replace y by x square. So what should be that term? Yes, what is the power?
X raised to power 5.
Not 5. X raised to 4 into x raised to 2.
About 6, 6.
6.
And what about this term?
7.
7 is a correct
7
answer. Now, one way is, yes, if you want, yes, everywhere, only the first two terms can be combined together because they have the same power. So you can take LCM and then you can integrate, or you can integrate and at the end you can take LCM. Let me integrate here directly. I'm not taking this. So the integration of x raised to 4 is x raised to 5 upon 5. So I will take x raised to 5 by 10, x raised to 5 by 15. No, not 15. 5 into 3. Yes, it is 15.
Sir,
Correct.
15.
Correct. X raised to 7 by
14.
and x raised to
14.
8 by
20.
24.
correct. Now, just you can use a calculator also to get this answer. You will get the answer to simplify at the end 0.053. But before that, yes, just you have to replace these values. When you replace these values, you will get 1 by 10 plus 1 by 15 minus 1 by 14 minus 1 by 24. No need to take LCM if you are not interested to write it in fraction. Just write the answer in decimal as 0.053. So choice is yours. You can write it with the help of calculator as a 0.053, or you can do it with LCM and you should get the answer 3 upon 56. If anyone have a doubt here, yes, you can ask. Is there any doubt?
Can you explain the last step, sir?
Last step is just we replace upper limit and
Yes,
lower.
yes.
It is simple
Okay.
algebraic integration, right?
Yes, sir.
Which step? This one, x raised to 5 by 10.
No, sir, I understood, sir. You have
Okay.
substituted one, sir.
Yes, we replace upper limit and lower limit. Correct. Just we replace x by 1 there. One of the most important part in double integration is getting the correct limit. That is the important thing. If you get wrong limit, then even though you do a correct integration with that wrong limits, you will get the wrong answer and you will lose your marks. So step number 1, draw the graph, highlight the shaded region or the region of integration. Shade the region, of a region of integration, and then take the strip that you want, vertical or horizontal. And once you take a strip, remember the strip is not stationary. It is actually moving. It is actually moving from this minimum point x equal to 0 to x equal to 1. When we drag it from x equal to 0 to x equal to 1, throughout you will observe this lower end of the strip. This lower end of the strip is touching to the curve y equal to x square, and the upper end of the curve touches to y equal to x. So the limit of y are throughout the region are from x square to x. So that is the lower and upper limit, and the outer limits are 0 to 1 there. Okay, so this way we get a limit. If you finish this, tell me, we'll move to the next question. Are you completed?
Yes, sir.
Okay, so I will move to the next slide now. Okay. So one last question on the type 2 here. And the question you can see, evaluate this double integral x square dx dy. You will observe the integrands are always really simple. Majority of the times they are algebraic only. Okay, you know how to integrate x square. Okay, so that's a very simple integrand. The main target or the main importance is getting the region of integration, correct region of integration, and getting that limits. So that is the main part there. So we have to evaluate this double integral over the region A, and this region A is bounded by, now we have the different curves. One is hyperbola, xy equal to 16, then y equal to x straight line, y equal to 0, and x equal to 8. So 4 curves were given. So we should draw these curves one by one. So let me take first the coordinate axis. So I will take this as say, majority of the times the region is in first quadrant, but not necessary. It should be only in first quadrant. It can be anywhere. So this is my x and y axis here. Which curve we will draw first? Say xy equal to 16. Okay. What is this curve? This curve exists in which quadrant?
First quadrant.
It is actually first and third quadrant, but we'll take only one branch of that. So the curve is oblique hyperbola that we see in xy equal to 1 curve we see in xy equal to 1 and xy equal to 16 is similar curves here. Then we have the next curve. This is I can say it is xy equal to 16. Xy is equal to 16. That's the first curve. There is one more curve this side. Okay, we are not taking it because the other boundaries are in first quadrant only. Okay, so that about one curve. Then I will draw the next curve, y equal to x. Yes, y equal to x is this curve, y is equal to x. Now these two curves intersect. So what should be this point of intersection? Yes, anyone? What should be this?
Sir, 4.
4.
4 comma 4, because xy is a 16 and y equal to x. So replace y by x here. X square is a 16, so x is a 4. 4 comma 4 is the correct point there. Okay. So that about this second curve. Now y equal to 0. Y equal to 0 is which curve? Yes, it's x-axis only. So this is y equal to 0. That is x-axis. Next, we want last x equal to 8. X equal to 8. Where we should draw? Last curve.
It's a straight line parallel to y-axis.
Very good. Straight line parallel to y-axis only. But this is x equal to 4 somewhere. So you cannot draw somewhere here. You have to draw other than that place. So let I draw somewhere here. So this is the last line. Say x is equal to 8. Now the main part starts. Whether the region is this sector, this like a sector, or this one. Which one? Is it a sector or the below sector? Yes, anyone? Region of integration is which one?
The lower one.
So
Okay.
below 1.
Okay, majority of says below 1, and someone said only this one sector. Okay, remember why this is not the correct region. This sector region is not a correct. The reason is it doesn't have all the boundaries. You'll observe this sector does not have a boundary y equal to 0. This y equal to 0 should be the boundary of the region, but that is not the boundary. So y equal to 0 is boundary here. Then this straight line comes here. Then we have this say hyperbola and then straight line. So the region of integration, this region of integration is this one. That's the region of integration. Any doubt, anyone, to identify the region of integration?
So, sir, we would take it in two parts while solving it.
Yes, correct. Okay, good. So you are a little bit ahead of the class, no issue. But yes, we've not seen any example where we require the two strip, and why there is a need of two strip. We'll discuss it. This is one of the most important example to identify the reason of the two strips there. Okay. So the question is, this is our region now, and our aim is to evaluate. Our aim is to evaluate this integral. The integral I that we are given is double integral x square dx dy on the region R. Okay, on that region R, or on the region A there. So whatever that region we have. But this region A now, this region A, we are going to split up as the region A1 plus region A2. What is the region? What is the reason that I will tell you? So this is the region A. The region A is a sum of A1 plus A2. And why there is a need of the splitting? Let me come to that part. Now I'm going to take the vertical strip here. Okay, so if I take a vertical strip like this, can you tell me what should be the lower limit and what should be the upper limit?
Sir, 0 to x.
0
0
x.
to x is correct. Lower end is touching to y equal to 0, but the upper end is touching to y equal to x there. Okay, you'll observe the lower end of the strip is touching or varying on the curve y equal to 0, while the upper end is varying on y equal to x. Then we'll come to the limits of x. What should be the minimum and maximum value of x over the region?
Sir, 0 to 8.
0 to 8
0
is
to
the
4.
correct answer. Okay, 0 to 8, you'll observe minimum value of x over the region is 0, maximum value of x over the region is 8. So x minimum is 0, x maximum is 8. Actually we should drag this strip from minimum value of x to the maximum value of x. So when we drag it from minimum to the maximum, you will observe the lower end is continuously varying on the same curve. So there is no issue, or there is no problem with the lower limit. But there is a very important part that you will observe on the upper end of the strip. When we move from 0 to 8, upper end will vary on the straight line first up to certain point, and after that it changes the curve, and because of that there is a need to divide the region into the two parts. So whenever, remember this important thing now, whenever either lower end or upper end varying on more than one curve, there is a need of splitting the region. There is need to splitting the region, and we should evaluate that double integral on two different regions there, not on the with the same limit, because the limits are changing there. So I will draw one vertical line here. This vertical line is mainly splitting the region part. So here is that vertical line. So I'll take a dotted line or I'll draw this line. So you'll observe up to this side the region is A1. Okay, up to this side the region is say A1, and after that I will say the region is A2. Okay, so from this point to this point, okay, from this point to this point is A1, and from this point to that point is A2. Indirectly from 0 to 4, I will say x equal to 0. This is x equal to 4 line, and this is x equal to 8 line. So from x equal to 0 to 4, the region is a A1, which is a triangle type region, where the lower end varying on y equal to 0, upper end will vary on y equal to x. But after that, when we come to that region 2, A2, then lower end will again vary on that y equal to 0. So lower end doesn't have the problem. Upper end will vary on y equal to
16 by x.
16 upon x.
correct 16 upon x. So that is the end of getting the limit. So what I will write it here now, that is the important thing. I will write a double integration. Now I will say x square dy dx. This is for region 1, and for region 1 we should have the limit of y first, which is a 0 to x. This is a 0 to x, and at the same time the outer limits of x. Yes, what is the minimum and maximum value of x over region 1? That is A1.
0 to 4.
0 to 4 is a correct answer. Good. plus now plus this is double integral now on the region 2 with the same order dy dx. And now you can tell me these limits.
4 to 8.
Okay, outer is
Outer.
4 to 8 and inner
0 to 16 by
16 minus x.
16 upon x. What is the most difficult part in this question is this one only, writing this limits for this double integral. Remaining part is now very simple. I know you can evaluate it because just you have to integrate with y first. And what is the integral of x square with respect to y?
x square y.
X square y, that's one. And just put upper and lower limit and do one by one integration and you should reach to the final answer as 448. Okay, you can finish. Those who understood, they can finish. And those who have the doubt, yes, you can ask me again. Is there any doubt there? There are very few examples. I will say there are very few examples where we require these two strips. Majority of the examples coming in the exam are with a single strip. Single strip examples are mainly coming in exam, but by chance if this type of the question also come, you should able to complete it. In this case, even though we'll take horizontal strip, that also require two strips. Okay, remember, because whenever horizontal strip is there, that also will not vary on the same curve. We'll discuss it about it. Okay, once we'll complete this calculation. So first step is really simple. This 0 to 4 as it is. Integral of this is x square y. So I will say x square y limits 0 to x only and dx plus 4 to 8 integral is x square y 0 to 16 by x. I will put upper limit and lower limit. Okay, just a minute. So we'll put upper limit and lower limit. If we'll put upper limit, or first integral sign is there 0 to 4. Yes, anyone? It become
X cube.
just x cube, correct?
X cube.
Yes, it is a x cube dx only. Lower limit it is 0, is it? Plus 4 to 8. And what about this integral?
16x.
Yes, 16x dx. Now again you can integrate this with respect to x now and put upper limit and lower limit and you should check whether you get 448 as answer. 448.
Yes, sir.
Okay, getting very good. Nice. So drawing the rough sketch is important and getting the correct limits is a very important part there. This is actually a solved example from a book. You can see the solution of this book in the textbook also. Okay, well, you can complete it. Once you finish, tell me.
Excuse me, sir.
Yes, yes.
Sir, I was doing the tutorial and I had a question in it. I wanted to ask that.
No, for
Sir,
tutorial, I will not clarify anything right now. I already told. After 19th only, whatever you know, whatever the way you should try, Okay, you have to think on the problem and you should complete it. Okay, so if you have something means related the question is wrong or that, then you can ask. But if you are asking some hint or something like whether you are correct or wrong, so I will not tell anything right now. Okay, just after 19th, whenever we have a class, we'll discuss that questions. Okay, is
Okay,
it
sir.
okay? So
Sir,
yes.
sir, I had a doubt in that differentiation preparatory course
No,
quiz.
differentiation you ask Joshi ma'am, that's better. Okay.
Okay.
Okay. If any doubt is there regarding how to upload or that things, yes, you can ask, but it is very simple thing that you have to do it. Once you finish writing on the paper, make a single PDF file, and just upload there. Okay, write ID number. Don't forget to write ID number on each page there. Okay. Without ID number, will not consider it. Okay, done. All of you completed this. Yes, already I told the marks are not important in the quiz of a preparatory. Important part is your attempt. You should complete that attempt, because when I remove the duplicate cells, because some of the students may completed it is a 2 times 3 times that quiz. Then when I remove the duplicate, it may happen that your second or third attempt marks removed, and only in that Excel you will find that previous marks there. So don't worry about it. Are you finished this?
Yes, sir.
Okay, good. So I will just want to show you here. This is the solved example in a book, and the same way whatever we done here also that completed. You will observe first that vertical strip is a taken vertical strip, and y equal to 0 to y equal to x, and it is 0 to 4. That about the region 1. For the region 2, it is from 4 to 8, that is outer limit, while y equal to 0 to y equal to x by 60. So that about vertical strip. If someone thinks about a horizontal strip, let I show what will happen. So if you want to take this horizontal strip, first this is the region. Okay, this is the entire region, and in that region you will take this horizontal strip like this. Okay, now what is the y minimum and y maximum over this entire region? What is y minimum?
0.
This is a line where y is 0, correct, and y maximum?
4.
4.
Yes, y maximum is 4. Somewhere here you will get y equal to 4. Okay, so when we take this strip, actually we have to drag this strip from y minimum to y maximum. So if we keep at y minimum, yes, it is varying on this same straight lines. But when we drag it up to y equal to 4, after a certain point, you will observe that point only, this one. This is the position. This is the position, or this is the line where which end is not varying on the same curve, lower or upper, or left or right, I will say.
Upper.
Yes, upper one. This upper end is varying on this straight line for up to this part, but after that this will moving on that part. So what is the equation of this line? What is the equation of this green line I drawn? Y is equal to
2.
2 is correct. So the double integral will go like this. Double integral x square, I will say, dx dy plus double integral x square dx dy. So y equal to 0 to 2. Y is equal to 0 to 2. We have one region, and from 2 to 4, 2 to 4 we have other regions. We got the outer limits. From 0 to 2 we take a region 1, and from 2 to 4 we take another region. Now can you tell me what will be the limits of x for the region between 0 to 2? Y equal to 0 to 2. Lower end is touching 2. We want the limit of x now. Yes, left hand is touching
Y is equals to X
y
curve.
equal to x. So what is the limit for x?
Y.
Y, correct. And what about the upper limit? What is the equation of this line?
8.
X equal to 8. So that's a correct answer. So the limit of x become from y to 8 here. And what about the other region now from 2 to 4? This is region A2. Here I will take one step. So tell me left limit. What is x equal to?
Y.
Y only. And what about upper limit? X equal to
16 by Y.
16 by y. So this,
16 by y.
yes, correct. This way also you can evaluate it and you will get the same answer. Choice is yours. But both way it is both way we have to split the region. So it's better to take vertical strip. That is mainly the simple here. But those who are not interested with vertical strip, remember, yes, you can do it with horizontal strip also. Is that clear? Any doubt? Is there any doubt?
No, sir.
That's good. Okay, so I'll move it to the next type 3 then. Just we'll see the introductory part of a type 3 right now. So type 3 is a change of order of integration. Okay, you'll observe the heading. You can give the heading in your notebook also. You can give the heading type 3 change of order of integration. Remember there are total 5 types that we have. Okay, so we are right now in the third type. Change of order of integration. Why this is required? Okay. Many times this inner integral is very difficult to evaluate or it is impossible to evaluate. In such a case, there is a need of change of order. Okay, that is one reason. That is main reason actually. But for all the numericals, all the examples that we have in our textbook or that are coming in old question papers, clearly they mention change the order and evaluate. So you don't have to think on that. Compulsory you have to change the order and evaluate it. Okay, so there are two things. One is obviously a question. Read the question. In the question it is written change the order and evaluate, so definitely you have to do that one only. But otherwise identification of change of order is inner integral is very difficult to evaluate, and you will observe whatever the numerical I kept on the slide. Can you evaluate it? Can you evaluate this integral with respect to y? This integration is impossible to evaluate. Okay, you cannot integrate with y. You cannot integrate this integral with y as it is, because this integration will go continuously, and it will never end by parts or any other method. You can't evaluate it. Got it? So because of this, yes, we can integrate first with x and then we can integrate with y. So there is need to change the order, but it doesn't means that when we change the order, this inner limit goes directly to the outer and outer goes to the inner, because when this inner limit goes outer, what happens? The outer limit becomes a variable, and we already know that outer limits are never a variable, so we cannot take it directly like that. What we have to do it first, we have to find out what are the boundaries of this curve. Okay, what are the boundaries of this curve? Those who will have those who are interested, they can check this question. Have one YouTube video I linked with that, and I given this link. You can take a time and you can see the regions there also. You can see that whatever we are discussing right now, it is hardly a 4-minute video only, maximum 4 minutes. Okay, you can see that. Okay, I generally prefer short videos. I'm not interested to give the very long videos. So this is 4-minute video. You can see this example of that. So let me solve this question here. Suppose this question we have this question, and question is solve evaluate this double integral. Now obviously we cannot evaluate this with y. You can apply any rule Tell me if you know, if it is possible to you, you can tell me the integration. Can you integrate this? Yes, anyone? Is it possible? Already I told that is not possible. So let me come to the limits. Tell me what are the boundaries? What are the boundaries for this uh, region of double integration? Because this limit gives us a boundary. Tell me what equation we get for this limit x.
Y is equals to X.
Correct, y is equal to x. Very good. So this is the important thing that you should know, because these are the limit of y. So this is y equal to x to y equal to infinity. So y equal to x, y is infinity. Then x equal to 0 to x equal to infinity. So step number 1, whenever we have to change the order of integration, step number 1 is always we have to write the boundary equation. I written y equal to x, y equal to infinity, x equal to 0 and x equal to infinity here. Now let me highlight the region of integration. Let we have to draw these curves there in a xy plane. So rough sketch again. So I'll take this as a x-axis and this one is my y-axis. So few curves, yes, we can draw it. First, y equal to x. Obviously y equal to x is this line. This is the line y equal to x, which make an 45-degree angle. Then x equal to 0. X equal to 0 is which curve?
Y
Y
axis.
axis.
Y-axis. So another boundary is x, y-axis. Correct. This one. So x equal to 0, y equal to x. Then x is infinity and y is infinity. Okay. So now x infinity and y infinity, these straight lines we cannot draw it. They are very. These are undefined. Okay. Infinity is itself undefined. So which sector is the region? It is this upward or this lower? Which one is the region of integration? Region of integration. See, x is 0, y equal to x. That should be in between these two. Okay, first thing we have this boundary now, y equal to x and x equal to 0. So the region should be between these two straight lines. So the region of integration is this one. Only the problem with this region is this is unbounded region. Okay, this region is infinite region. It is unbounded. Okay. So step number 1, we identified the region now. We got the region. Tell me, when we return these limits x to infinity and when the order is a dy dx, what was the position of a strip there? What was the position? They have the vertical strip,
Vertical.
but we have to change the order. We have to change the order. So what should be the new position of the strip?
Horizontal.
We should take a
Horizontal.
horizontal strip.
Horizontal strip.
Now new strip we should take horizontal because we have to change the order. We have to change. Already there is a dy dx. Dy dx means they have the vertical strip. And the question is right now the change the order. We have to change the order. So we taken a horizontal strip. Compulsory we have to take horizontal strip now. Okay. Now tell me the lower limit and upper limit. What is the lower limit for x?
0.
And upper limit?
0. Y.
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 Correct. So our new double integral will become with a change of order, x varying from 0 to y, e raised to minus y upon y, and the order now we are taking dx dy. We are taking the order dx dy. So what should be the outer limits now? Outer limit should be for now y there. What is the minimum y and maximum y over the region? Minimum y is obviously 0. And what about a
0.
maximum? Infinity.
Infinity.
Sir,
Yes, it's a 0 to infinity
infinity.
is the correct answer. Good. And that's the change of order. This is not so new here. Important thing, you have to find the region and now you can see, you can very, very easily, you can evaluate it. So outer 0 to infinity as it is. What is integration now? What is integration of inner? This e raised to minus y upon y is a constant as it is because we are integrating with x. And limits are 0 to y. And that dy is there. Now we can put this limit and we left with e raised to minus y upon y into y only, and that is a dy. And you will observe this y which creates the problem for integration gets cancelled, and now we can integrate e raised to minus y, and integration of e raised to minus y is e raised to minus y upon minus 1. And what is the e raised to minus infinity?
One.
E raised to minus infinity is a 0, not 1.
Zero.
And e raised to 0 is 1. Lower limit of the minus sign, that minus minus becomes plus 1. So the answer of this integral is just 1. 1 is the final answer there. But what is the most important thing is change the order. Change the order so that we can evaluate this double integral. Okay. So generally the question comes, remember, even though I written the question, just evaluate. In exam, these questions are coming, change the order and evaluate. Change the order and evaluate there. Any doubt here?